Welcome to Aeromotive Industries. When you look at an EV rolling off the line, you easily see the steel chassis and the battery packs. These materials and the wages of the line workers assembling them flow directly into the cost of each vehicle. But look past the assembly line. The massive power grid keeping the robotic arms moving, the climate control systems maintaining safe battery temperatures, and the cafeteria feeding the engineering staff, none of these physical systems touch the cars directly. These critical, invisible pools of support expenses are what we call overheads. They are the cost incurred for general output, not a specific unit. To manage these expenses, we first classify them into production, administrative, and selling and distribution overheads. Once categorized, we track those expenses to a single product. The framework moves through accounting and control, distribution of overheads, and finally calculating precise overheads rates. Capturing and assigning these invisible costs accurately is the only way to calculate the true final cost of an EV. Without this process, a company risks setting a sale price lower than its actual production cost. The distribution process starts as soon as the factory receives an invoice. The first step is getting that cost into the right departmental bucket. If an invoice can be traced entirely to a single department, like the assembly department supervisor's salary, we use a process called allocation. The entire expense drops perfectly into that one specific container. However, a single invoice for the monthly factory rent covers the entire building. We can't dump that into just one department. Instead, we share it using a logical metric. For rent, we measure the floor space each department occupies. We then divide the total cost proportionally based on that square footage. This indirect sharing is called apportionment. The distinction between the two lies in traceability. Allocation is a direct assignment to one specific center, while apportionment relies on mathematical logic to share a common cost across many. Support teams like the canteen or the powerhouse don't actually manufacture cars. Therefore, all the costs we just allocated and apportioned to these surface departments must eventually be flushed out into the primary production departments. We call this secondary distribution, or reapportionment. Here we hit a roadblock. Service departments often serve each other. The powerhouse generates electricity for the canteen's ovens, and the canteen feeds the engineers running the powerhouse. It creates a continuous loop. Let's look at the baseline numbers. The canteen has accumulated $300,000, and the powerhouse has $60,000. The canteen provides 10% of its meals to the powerhouse, while the powerhouse sends 20% of its energy to the canteen. Grab a piece of paper and pause the video here. Try to translate this continuous visual loop into two simultaneous algebraic equations representing the total costs. To find the total cost of the canteen, which we'll call X, we start with its $300,000 baseline and add 20% of the powerhouse's total cost, Y. So X equals 300K plus 0.20Y, and Y equals 60K plus 0.10X. If you prefer to avoid algebra, you can use the repeated distribution method instead. You distribute the costs back and forth according to their percentages, repeatedly, until the remaining fractions shrink down to zero. Regardless of whether you use simultaneous equations or repeated distribution, breaking this reciprocal loop is a mandatory mathematical step. It ensures every last dollar of service cost is pushed out to the production line. All of those overhead costs, having survived reapportionment, now sit pooled entirely within the main production departments. The final step is injecting them into the cars. A century ago, manufacturing relied heavily on human labor, so overheads were often absorbed based on worker hours or wages. But Aeromotive operates a heavily mechanized floor. If we tried to apply a traditional percentage of direct labor rate here, we would calculate heavily distorted product costs. The machines are doing heavy lifting, consuming the power and requiring the maintenance, not the manual workers. In a highly automated environment, the correct base is the machine hour rate, the specific cost of running a machine for 1 hour. If the rate is $848.18, and this robotic arm works exactly 2 hours, we inject exactly $1,696.36 into that vehicle's final cost profile. Let's review the pipeline. We accumulate the raw invoices, we use allocation and apportionment to sort them, we perform reapportionment to break the service loops and push costs to production. Finally, we use an accurate rate for absorption. Executing this step-by-step flow transforms chaotic, invisible facility expenses into a controlled, precise metric. It ensures that when you set a final price for your product, you guarantee profitability on the factory floor.